Hello dear student, this is my Mahato sir. Today discussion a topic unit and dimension topic principle of homogeneity. So here today discussion a simple interesting topic principle of homogeneity. What is principle of what is principle of what is principle of homogeneity, and then some numerical problem related to the principle of homogeneity. So what is principle of homogeneity? Principle of homogeneity a rule. So a equation same equation the physical quantity add or subtract same nature in unit and dimension. So here principle of homogeneity, what is principle of homogeneity? So principle of homogeneity a rule. So this rule is a equation some physical quantity add or subtract when the two physical quantity so two physical quantity same nature. Suppose here x equal to a plus minus bt. So here a and b same dimension, a and b same dimension. So a and b same dimension because rule of the principle of homogeneity. So two physical quantity add or subtract when two quantity same nature. That means suppose here suppose here a and b same nature. Here 5 kg 5 kg 5 kg chini, here 5 kg chini. So 5 kg chini 5 kg chini, so same nature. So two quantity add or two quantity subtract. That means two quantity same nature. Now here principle of homogeneity rule, we write here all the term suppose here all the term principle of homogeneity rule, all the term add or subtracted, all the term add or subtracted in a equation, all the term add or subtracted in a equation, all the term add or subtracted in a equation have same unit and dimension, same unit and dimension. here x equal to, suppose example here equation here x equal to equation here x equal to 80 plus x equal to 80 plus b into t square, x equal to 80 plus b into t square. Here a and b are constant, and x and t are variable. X and t are variable here. So dimension of x equal to dimension of 80. Dimension of x equal to dimension of x equal to dimension of x equal to dimension of 80. Dimension of x equal to dimension of 80. Here dimension of x equal to dimension of 80. Dimension of x equal to b into t square. So this equation so dimension of x and dimension of 80 here find out a, dimension of x, dimension of bt, here find out constant. So this equation find out a, and this equation, these two equation, these two term equal, then here the final out. So value of a find out or value of b find out. So this important rule or important concept, principle of homogeneity rule, now must be important for both student or any competitive exam, for both competitive exam. Various STET exam, various TGT, PGT or board exam, both student more helpful. So now this interesting or beautiful principle of homogeneity rule. So now screenshot this formula and now start numerical problem. So start important numerical problem. Please I think screenshot complete. So now it is this principle of homogeneity rule. Here first one, question 1, b equal to a plus bt, b equal to a plus bt. Here b equal to velocity, v equal to velocity, t equal to v equal to velocity, t equal to time, v equal to velocity, t equal to time. here v equal to velocity and t equal to time. Find the dimension of a and b. Find the dimension of a and find the dimension of a and b. Find the dimension of a and b. Now, which principle of homogeneity rule? Here v equal to a plus b2. So here two quantity add or subtract because two quantity same nature. But because two quantity same nature, here firstly here b equal to a plus bt. So b minus here minus a here left hand side. So change right hand side and left hand side changes. So a minus a, firstly this this term left one side. So minus a minus of here bt, all term replace right side to left side equal to 0. So v minus a minus bt equal to 0. v minus bt equal to 0. Now dimension of a, now here dimension of a equal to dimension of a equal to dimension of v. Dimension of a equal to dimension of v. So here dimension of a. So dimension of v equal to dimension of v equal to L by T. So v dimension is L by 2. V dimension is L by 2. So here write LT power minus 1. So a dimension find out LT to the power minus 1. Secondly, find out dimension of second dimension. First here dimension of physical quantity a constant find out, and second is b constant find out. Dimension of, now related to dimension of compare here. So two quantity add or subtract here. Two quantity add or subtract when two quantity same nature. So two quantity add or subtract when two quantity same nature. So this term equal from homogeneity principle rule. So now dimension of bt, dimension of bt equal to dimension of bt, dimension of bt equal to dimension of bt equal to dimension of v. Dimension of bt equal to dimension of v. Now dimension of, so here bt equal to dimension of v. So bt dimension of v is dimension of v is L by T. So b equal to L by T. Here T. So b dimension L by T square. So b dimension L by T square. That means here write down b equal to LT minus 2. So two quantity so constant a dimension is LT power minus 1. Constant b is dimension LT minus 2. Question number here 1. Question number 1. The next problem. Quickly write down. Quickly write down this problem. Then now second problem. Now start here. So quickly write down. I think video quality and light or sound also both are best. So because time is 5 p.m. Now completely second physical problem start now. Because video is long, so now start second physical quantity. So next second problem. So completely now erase. Now second problem. Question number second here. X equal to here x equal to a plus c by m, x equal to a plus c by m, x equal to a plus c by m, x equal to displacement, m equal to mass, find the dimension of A and C. Find the dimension of A, find the dimension of A and C. Find the dimension of A and C. Find the dimension of A and C. Second problem here related to homogeneity principle rule. Now start here. Here above equation or given equation is x equal to a plus c by m, x equal to a plus c by m. This now x equal to x minus a minus c by m equal to 0. So now this equation now dimension of x equal to dimension of x equal to dimension of a. So dimension of x is L. So dimension of a, so a dimension here, dimension is L. A dimension is, so constant here constant, so constant dimension is L. Second here dimension of x equal to dimension of c by dimension of x equal to dimension of x equal to dimension of c by m. So dimension of x equal to L, dimension of x equal to L, equal to here c by m. C, so m dimension is m. So m dimension is m. So c dimension is c equal to ml. So C dimension is ml. So T here absent, so T 0, right? Here T is the time, T also to T dimension here absent, so also added T0 because T0 equal to 1. So now here right. So dimension of C is M L T0, ML T0. Now second, then problem number is third. Write down, quickly write down. Now there is this problem. Now start numerical number 3. Now start numerical number 3. So quickly 1 second time screenshot or other process, any choice. Now now video is long, so now erase this problem. I think screen sheet complete. Because here 7 to 8 problem today discuss here related to homogeneity principle. So 8 to 7 numerical problem help also body student and any competitive exam other. So any competitive exam, TGT PGT level or state exam or various exam related to homogeneity of principle. So 7-8 problem totally discussed. So 1 hour's time. Question number third. Here. Question number third. Mu equal to a plus b by lambda square. Equal to a plus b by lambda square. Here mu is the refractive index. Or here lambda is the mu is refractive index, and lambda is wavelength. Lambda is wavelength. Find the dimension of here. Find the dimension of A and B. Find the dimension of A and B. So now here given equation is mu equal to a plus b by lambda square equal to a plus b by lambda square. So mu minus of a minus of b by lambda square equal to 0. So now this equation compare from homogeneity principle rule. So dimension of dimension of A equal to dimension of mu. Here mu is a refractive index, mu is a refractive index, mu is a refractive index. So mu is the refractive index. Mu is a refractive index. So mu is a constant quantity. Mu is a constant quantity. So constant quantity have no dimension. So dimension of A equal to mu is no dimension. So A equal to M0 L0 T0, because mu equal to refractive index, or refractive index is a constant quantity. So constant quantity have no dimension. Here now compare dimension of mu equal to 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 dimension of b by lambda square. So dimension of mu equal to b by lambda square, b by lambda square. Here wavelength, here wavelength meter in, here wavelength meter wavelength measure. So here wavelength measure meter, wavelength measure meter. Here wavelength measure meter. So dimension of L. So mu equal to mu so b by wavelength is measure meter. So meter is length L. So here b by so length, meter is a length dimension is L. So dimension is L square. Dimension is L square. So b equal to mu into L square. So b equal to mu dimension M0 L0 T0. So dimension of L square M0 L square T0. M0 L square T0. Then next problem number here 4. Now problem number 4. The question number 4. In a next here in a next problem here, in a vendor wall next problem in a vendor walls in a vendor wall equation 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 here vendor wall equation p plus a by v square p plus a by v square v minus b p plus a by v square v minus b equal to rt. In a vendor wall equation p plus a by v square v minus b equal to rt. The dimension find the dimension of a is 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 9 find the dimension of a is 9 find the dimension of a is 9 into centimeter to the power 4 9 into centimeter to the power 4 9 into centimeter to the power 4 9 into centimeter square 9 into centimeter square 9 per centimeter cube 9 per centimeter cube 9 centimeter 9 centimeter. So here this problem here various PGT exam various STET exam. So various competitive exam very important point. So here a vendor wall equation given a vendor wall equation p plus a by v square v minus b equal to r2. Then the dimension of a is here 9 into centimeter to the power 4 9 into centimeter square 9 into centimeter cube. Now here start given equation here principle here is principle of homogeneity rule. Principle of homogeneity rule principle of homogeneity rule in a equation two quantity in a equation suppose in a equation two quantity add and subtract when two quantity same nature same nature from concept of homogeneity rule here x equal to a plus minus bt. So two physical quantity two physical quantity add or subtract, two physical quantity add or subtract, and two physical quantity same nature, and two physical quantity same nature, and two physical quantity same nature, two physical quantity same nature. So now use principle of homogeneity rule. Principle of homogeneity rule here. Here dimension of B equal to dimension of V. So dimension of B, so V dimension is L cube. V dimension is L cube. So V L cube. So centimeter here is cube. But here dimension of A find out dimension of A find out A, dimension of find out A, but here dimension find out B. Next here dimension of, now compare dimension of P. Now dimension of P equal to dimension of P equal to dimension of A by B square. Dimension of P equal to A by B square. So dimension equal to A into P into B square. So dimension of A, P equal to, here P is the pressure, the pressure is force per unit area. Pressure is the perpendicular, pressure is a force per force. So pressure P, here P is the pressure force per unit area. P is the pressure force per unit area. So P is the pressure. So here P replaced by F by A. P replaced by F by A. P replaced by F by A. P is the pressure. So pressure is the force per unit area. Pressure is the force per unit area into here B square. So totally put the value of dimension. So force dimension 9. Volume dimension here centimeter cube, centimeter. So volume centimeter square. So volume dimension centimeter square. So volume dimension is here volume dimension of V, volume dimension centimeter cube. Volume dimension is centimeter cube. That means V equal to L cube. So here dimension V dimension is or V unit is centimeter cube. Into V unit is centimeter cube per square. Here area dimension is centimeter square. So area dimension is centimeter square. So A equal to here, A equal to 9 here centimeter per 6, here centimeter square. So here cancel. So A is 9 into centimeter to the power 4, 9 into centimeter to the power 4. This is the required answer. This is the required answer. 9 into centimeter to the power 4. 9 into centimeter to the power 4. Complete. Now this problem, write down. So now important note here related to this problem, important some additional some important point added this problem, some important added this problem. Now complete this numerical problem or screenshot completely. Now now here discuss now here discuss this program related important concept. So now totally so completely write down. Now erase this problem. Here a important concept. Here two type of gas. One is real gas. Two types here. One is real gas, other is one is real gas, other is ideal gas. One is real gas, other is ideal. So gas here so gas two type. One is real gas, one is real gas, others is ideal gas. Real gas equation. Real gas equation for 1 mole. This is the important point. This is the important concept or important point. this is the important concept or important point. Real gas equation for 1 mole, 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 P plus A by B square, P plus A by B square, V minus B equal to RT. P plus A by B square, P plus A by B square, P plus A by B square, V minus B equal to RT. Here A equal to constant, A equal to constant. Ideal gas equation here, ideal gas equation, ideal gas equation for ideal gas equation for 1 mole, ideal gas equation for 1 mole, ideal gas equation for 1 mole, PV equal to ideal gas equation for 1 mole, PV equal to RT, PV equal to RT, PV equal to RT. PV equal to RT. So here ideal gas equation, any temperature and pressure follow Boyle's and Charles law. So ideal gas equation, ideal gas equation, ideal gas equation, any temperature and pressure, ideal gas equation, any temperature pressure, ideal gas equation. Here ideal gas equation, any temperature pressure follow Boyle's Charles law, Boyle's Charles law, and others is real gas. So follow Boyle, follow any every temperature and pressure follow Boyle's and Boyle's law, Charles law. This is the ideal gas, or others is the and Boyle's and Charles law. Boyle's any temperature pressure do not follow Boyle's and Charles law. This is the real gas, So ideal gas equation, ideal gas equation follow every temperature and pressure. So ideal gas equation follow every temperature and pressure, Boyle's Charles law, but every temperature pressure do not follow here, and do not follow here, do not follow Boyle's law and Charles law. Every temperature pressure do not follow Boyle's and Charles law. So this is the ideal gas, this is the real gas, this is the ideal gas, this is the real gas. Boyle's or Charles law follow, but here do not follow Charles. Here write down any temperature pressure and pressure follow Boyle's and Charles law, but any temperature pressure do not follow Boyle's and Charles law. This is the important concept. Write down the next problem here. Discussion. Now it is this concept. This is the important concept. This is the important concept. This is the beautiful concept for various competitive exam. So now it is this problem. It is this important concept. Now question number here 5. The dimension of the dimension of A and B. A and B are a constant quantity. The dimension of A by B in the relation. The dimension of A by B in the relation. The dimension of A by B in the dimension of A by B in the relation P equal to the dimension of A by B in the relation P equal to here P equal to A plus X, P equal to A plus X by B, P equal to A plus X by B, where P is the pressure, X and X is distance, where P is pressure and X is distance, where P is pressure and X is distance, sir. Here option is M per M1 L to the power minus 1, M1 L to the power minus 1, M1 L to the power minus 1, T to the power minus 2. Second option is M1 L1 T power 2, M1 L1 T power 2. Third option is M1 L power 2, M1 L power 2 T minus 1, M1 L power 2 T minus 1. Then fourth option is M minus 1 L minus 2, M minus 1 L minus 2 T minus 1, application of homogeneity. Application of homogeneity principle. Application of homogeneity principle. Here given relation is P equal to given relation P equal to A plus X by B, P equal to A plus X by B. So here P equal to, here write P equal to A by B plus X by B. So two quantity add or subtract, two quantity add here, two quantity add or subtract. Application of homogeneity rule, because same nature, So dimension of P equal to dimension of A by B equal to dimension of X by B. So dimension of P, dimension of, so here dimension of P by B equal to X by B. X by B. So A by B equal to P equal to X by B equal to X by B. So here, so here X is, so X dimension is now here A by B. Now here this quantity found out, A by B find out, this quantity find out here. So here A by B equal to P. A by B equal to P, and P is force per unit area. P is the force per unit area. So P is the force per unit area. P is the force per unit area. So A by B, so force dimension is M L T minus 2. Here dimension of A is L square. Dimension of A is L square. Dimension of A is L square. So here L cancel. So A by B M power 1 L power minus 1 T power minus 2 This is the required dimension. Here M power 1 L power minus 1 L power minus 1 here L power minus 1 or T power minus 2. So here the match, this option match M power 1 L power minus 1 T power minus 2. So option is A is right. Option A is right. M power 1 L power minus 1 T power minus 2. Now problem number 6 here. Now problem number 6. The distance x travel by an object the distance x travel by an object in time t. The distance x travel by an object in time t is given by t is in time t is given by x equal to a plus a plus b by t square, x equal to a plus b, x equal to here x equal to a plus b into t square, x equal to a plus b into t square by a. So x equal to a plus b, x equal to a plus b t square by a. The dimension of a and b are 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 l square t minus 2. Second option is l t minus 1. Third option is l t minus 2. Third option is l t minus 2. Then third option is l and l t minus 2. Here fourth option is l square and l square t minus 2. Then l square t minus 2. This is the important problem for any TGT or TGT exam or board exam student, any competitive exam. Any competitive exam, most important, this is this problem. So here now dimension of x travel by an object in time t in given by x equal to a plus b t square by a. So dimension of a and b find out. So now problem completely write down. here equation is x equal to a plus b t square by a. Here x is x is distance. Here x is distance. Here x is the distance. Here x and distance are here. A and B are constant. Here A and B find out. Here A and B constant find out. Here x is the distance. Here x is the distance. A and B constant find out, and t is the time. T is the time. Now use principle of homogeneity rule. Use principle of homogeneity rule. Now principle of homogeneity. Principle of homogeneity rule. Now use principle of homogeneity rule. Dimension of x equal to dimension of A. Dimension of A equal to dimension of b t square by A. Now first here dimension of x equal to dimension of A. So x dimension is L. Dimension of A. Second here dimension of A equal to dimension of b t square by A. So dimension of A equal to here b t square by A. So here bt square equal to a square. So bt square equal to a square. Then b equal to a square. So b equal to here b equal to a square by t square. So b equal to here dimension of A is L square by t square. So dimension of B is L square by t square. So b equal to L square t minus 2. B equal to dimension of L square t minus 2. B dimension is L square t minus 2. B dimension is L square t minus 2. Here L square t minus 2. Dimension of A dimension of A is L. Here option A is right. Because dimension of here dimension of L, A dimension L, A dimension here L, b dimension here, b dimension L square t minus 2. Here b dimension is L square t minus 2. B dimension L square t minus 2. B dimension is L square t minus 2. So completely clearly discussion 6 problem related to homogeneity principal rule. I hope this 6 problem very helpful for any competitive exam or other board exam student. So good day. Today lecture now close, and have a good day. Now problem next day interesting topic, and interesting concept discuss, and this related problem today. That why now.